we talk how we could create a wallet and what's happened when we actually create the new one, what the encryption seed, and how we manage all our keys. So please take a look to my previous video. Today we will have a fun with the SDK. So and what we could do with the our wallet right now, and what we could do with the VCs. So as usually some pre-installation things. So for this example, we just need to have our SDK. It's enough. I will talk about a bit complex topic. So last time we was talking what the VC is and how the VC looks. Today we will try to issue not just a VC but the revocable VC. But what we should do? For sure, we should just import our create wallet factory, create the factory, and then we go and what we should do, we prepare the options. To prepare the options, we need to have our API key hash, so you could go to our registry and obtain the new, or you should have your key from the previous examples. So I already entered the key here, so just to speed up and how our options look like. We say that we want to use the production environment and we specify our production key. So that's actually it. So, and now we should create the two wallets. We should create the issuer and holder. Why we need holder? Because you could not just issue VC if you don't know to whom you want to issue it, because the holder ID is the one of the mandatory sections. So what we could do, we create the one wallet for the issuer, one wallet for the holder. That's it. So now we finished the pre-installation part. We have two wallets. We have the issuer that will issue the VC, the holder that actually will receive the VC in the future. So let's construct something that we called unsigned VC. So unsigned VC is super simple. It's nothing fancy. So every VC, as you know, is the JSON LD format. So every VC should have the schema. So I haven't found the schema for my case, so I decided to create the schema from scratch. We use our schema manager. So how the schema is look like, I want to issue the special type of VC, the content like. So it's mean that I like some content in internet. So here we have the URL of the content, we have the date where we have watched this content, the optional score that I could say actually how much I like it, so it's more even than boolean and just a boolean like. So it's mean that if I like some video, I will issue this VC for this particular video. And now let's construct the we have the schema. So what we should have, first of all, every VC should have the unique ID. So to produce this ID, actually I just use the simple algorithm, but you could use the UUID. So on my last videos we already talked how the credential look like, but as you could see, we have the context. We have the context, and inside the context we say that this verifiable credential is the, and that's the content like with the schema that we defined before. So now the JSON LD is happy, and as you could see in the data, we have this line that repeat the same information, that this particular object should be this particular type. And now we actually specify my favorite video about the verifiable credentials. If you haven't take a look, take a look. I say that I like it, and it's 10 out of 10. And yeah, the issuance date we could specify right now, and the expiry date, it's yet another possible thing that your VCs could be expirable VCs. So we support this feature, so we could specify that maybe in a 2065 it will expire. And what we get back the VC, unsigned VC, and you see that in a holder section we have the holder DID. It's quite important that we issue in the VC for the particular holder. So, right now this VC, it's practically ready. We could sign it and we finish our flow. But, what will happen if I will change my mind and decide that video maybe was not so good and I want to say that, no, I don't like it. So, and we have couple of problems right now. First of all the VCs are immutable and it's owned by holder. And once you issue it, you could not control the VC anymore, actually. And for this thing, we have some special type of VCs. It's called the revocable VCs that have a cool feature. So if you don't even control the VC itself, you control something that are issuer specific. You control the revocation list. So it's based on the open standard. So it's revocation list 2020. So it's the long, interesting specification. But if we keep it in short and go to the concepts, so it's super simple that we have the special type of credential that will have the bit string of the array of bit strings, and for every VC that issuer will issue, we will have the special index in this bit string. And if you want to revoke the VC, you find the index of the VC in a bit string and say that this VC is not valid anymore. So it's quite cool, it's quite complex, but let's discover further how it will look like. So what we should do to turn our unsigned VC to this revocable VC, we actually hide all this super complex flow with all the service interaction and authorizations and so on, because on practice only the issuer have the access to his revocation list, and only the issuer could revoke the VC. So we hide all this complexity in our SDK. If you have the instance of SDK, only one thing that you should do is just to say build revocation list status, put your unsigned VC, and you will gets back the revocable VC. So the revocable VC is slightly different from what we have here. So as you could see, we already have in a context some special type of VC that say that this VC is not just a regular VC, but it's revocable VC. Data stayed the same. But now we see quite interesting section as credential status, and in a credential status we have something like revocable list status. You could see the revocation list index. So as far as we just create the new wallet, so it's the new issuer, and in this new issuer he have his revocable list, and in a revocable list our VC is the first one. So, and we have the link to the credential. And actually, let's try to do the crazy thing. Let's try to fetch this credential and take a look how this credential look like. And as you could see, so this is the result of our fetch. It's a full-scale credential with the proof and signature, and inside it have a revocation list, and inside this revocation list, inside the credential subject, we have our encoded bit vector. So here it looks like an encoded thing, but what it's though that we have the limit of 100,000 of credential. We have the huge array of the bit array with the zeros and one, and right now we say that actually our credential is just the first index of this array. So every time when issuer issued a new VC or revoke the revocable VC, he will update this credential and publish it on the same actually the URI. And our revocation API service takes care about all this revocation list and revocable VCs. So to finish the process, we should actually sign the VC. So, the issuance on the edge is super simple. You build the VC, you sign the VC, and optionally, you now could share the signed VC with the holder in any way. So, for example, we could grab the instance of the holder SDK and store it, or whatever. It doesn't matter. For our example, it's not so important. But we go and say, signed, unsigned credential and put our revocable VC here. And you see here nothing changed, but right now we have two additional fields. First additional field is the issuer. So it's our issuer DID. As you remember, the DID is used to share our public keys. And the proof. And proof, it's actually the signature. So these two fields together correlates because the signature of this GVS signature actually will be validated by the private keys that will be resolved from the issuer DID. So now we are done. Actually, we are done with issuance, and issuance on the edge is super simple. You build it, you sign it, you are done. Now let's talk about the verification. So verification on edge, it's even more simpler. You don't even need a wallet. You actually could use our Affinidi common and fetch some credential cryptography tools that are platform specific. That's why they are separate. So what we need, we just need to construct something like the verifier. So it's the special class that gets the registry URL, because we will actively resolve the DIDs and do all the things. And the IP key for sure that you already have. And what we could do to verify credential, we could just call the validate credential method, and we gets back actually our result. And as you could see, the result for our newly issued credential is true. So everything is okay, and we don't have any kind of errors. Nice, super cool. And now what we could do, we could change our mind. So I don't like this video anymore. I decided that no, it's not so good. I don't understand what this guy is talking about. So I just specify the idea of the verifiable credential and some reason why I revoke this. And when we run this process, now we could repeat the procedure of the verification. So we get absolutely the same VC. It's not changed. It's absolutely stayed the same. And now we just repeat our verification. And what happens? What happens? We get the result false. And we have the statement that this particular VC with this ID, we have the problem that credential revocation status check result was negative. So it's mean that our credential is revoked. So we actually together with you with this simple notebook, what we did the issuance of quite complex revocable credential. We was able to verify and we was able to revoke this credential. So it's the basic operations that we could do with our VCs on edge. So, and in our next videos, we will talk how actually to share the VCs and what kind of other capabilities we offer to keep your VCs somewhere in the cloud, to share your VCs with somebody, and what's to do if you don't want to do the edge cases, what's to do if you want to use the platform